Year 3, welcome to Thursday's maths video for this week. We've spent Monday, Tuesday and Wednesday looking at turns and angles in shapes and other pictures such as letters. And for the next couple of days we're going to be looking at lines in shapes and in other sorts of diagrams. Now, what I'm going to do in this video is I'm going to go through the learning for Thursday and then also the learning for Friday as well in the same video because it does link very closely together. So you can watch all of the video on Thursday, that is absolutely fine. Tomorrow on Friday, if you want to come back and re-look at the video, particularly the second half, and I'll be very clear about when the second half starts, then you might find it really helpful for your learning on Friday as well. But today, Thursday, we're going to be looking at recognising horizontal and vertical lines. So we describe lines as horizontal or vertical, and a horizontal line runs across from left to right or right to left, like this, and a vertical line runs up and down or down and up, like this. And if you look at this shape here, have a look and see if you can spot where are the horizontal lines. I'll give you a little while to have a look and see if you can spot the horizontal lines and count them for me. Okay, there they are. Hopefully you spotted the top and the bottom line. And then now, where are the vertical lines in the same shape? Remember, some lines may not be horizontal or vertical. There they are. They are the lines that are running from up to down or down to up. And hopefully you've picked up on by this point that there are two lines in this shape, this one here and this one here, that are neither horizontal nor vertical. We call those lines, in fact, diagonal lines. Part of this lesson as well, there is a really important section on it to do with symmetry, and you will have looked at symmetry when you were at the infant school, but it carries on and gets slightly more tricky as you go through the junior school as well. When we look at where there are lines of symmetry in shapes and objects, we can talk about a vertical line of symmetry. And a vertical line of symmetry is when the symmetrical line goes from the top of the shape down to the bottom. So, for example, in this butterfly here, we have a vertical line of symmetry because in order for each half of the shape to be symmetrical, so looking exactly the same on either side, the line of symmetry has to go vertically. If we had a line of symmetry that was running horizontally across this shape, this butterfly here, then the two halves would not be symmetrical. They would not look exactly the same on either side of the line of symmetry. So we have a vertical line of symmetry in a butterfly, and then the right-hand side is symmetrical to the left-hand side. We do have horizontal lines of symmetry though, as well. In this arrow, for example, there is one horizontal line of symmetry that goes from left to right or right to left, like this. And you can see there the top half of this arrow is now symmetrical to the bottom half of the arrow down here. If we had a vertical line of symmetry on this arrow, then the left-hand side would look very different to the right-hand side. So we do not have a vertical line of symmetry in this arrow, we only have a horizontal line of symmetry. This is an activity to do with lines of symmetry and letters, and you might recognise this diagram here that's shown by these two circles that overlap each other. This is called a Venn diagram, and it's a way of sorting information so that we can see it very clearly. Now, in this Venn diagram here, this section of this left-hand side hoop, in it we put shapes that have only vertical lines of symmetry. And the shapes we're going to choose from today are those letters. In this right-hand hoop over here, in this large section of the right-hand circle, we're only going to put shapes that have horizontal lines of symmetry from this choice of letters over here. And then this middle section here, it's called the intersection, where the two circles overlap. What do you think we put in this section here? Have a think. We put in letters from the selection that have both a vertical and a horizontal line of symmetry. So now is a good time to pause the video and have a look at those 9 letters in the blue box, and can you try and organise them into the correct section of the Venn diagram. So in this section here, shapes that only have a vertical line of symmetry. In this section here, shapes that only have a horizontal line of symmetry. In this section here, in the middle, the intersection, letters that have both a vertical and a horizontal line of symmetry. And if there happen to be any letters that have no lines of symmetry, they need to be placed on the outside of all of the Venn diagram, so not in any part of the Venn diagram. So pause the video now, see if you can organise the letters, and then you can play it again and see if you got the answers correct. Okay, I'm just going to show you where each of these letters should be placed in the Venn diagram, and you can check your one at home to see if you got them correct. There you are. Well done. I hope you enjoyed that little activity there. Okay. This is where we need to now be having a look at Thursday's worksheet from the website. Have a go at it. You can look back at this part 1 of the video at any point if you would find it helpful. There is also the answer sheet on the website too to have a look at your answers as well. Now is the time where I'm going to come out of Thursday's lesson, and I'm actually going to bring up the information that we need for Friday's lesson. So if you want to log off here and move on to Thursday's work, you can, and have a look at this tomorrow, or you can have a look at this today as well as tomorrow. It's up to you. So Friday's learning for maths is to identify pairs of parallel and perpendicular lines. 2 really good mathematical vocabulary words there to focus on. So parallel lines, first of all, these are lines that run alongside each other in pairs. If they carried on and on and on and on forever, they would never ever meet. They would never ever touch. They are always the same distance apart. So here is an example of a pair of parallel lines. They always come in pairs. They're never singular on their own. And if those 2 lines continued in the position they're in, they would never ever meet. In maths, we show parallel lines in shapes or in diagrams by putting those little arrows on them. It shows us they are parallel lines. Perpendicular lines are pairs of lines that meet at a right angle, and we should be familiar with right angles now from earlier on this week. So this here is a pair of perpendicular lines. They always come in a pair. There's always 2 of them because you need 2 lines to make a right angle, and perpendicular lines are always associated with right angles. You can see the right angle here. Hopefully this is familiar from Monday and Tuesday in particular. So perpendicular lines are usually marked by using the right angle symbol at the point where they meet. There is a variety of shapes now on the screen for you to have a look at. Looking carefully at these shapes, how many pairs of parallel lines can you see in each of these shapes? So this will be a good time to pause the video, have a look at each shape very carefully and make a note of how many pairs of parallel lines you can see in each of the shapes. Bear in mind, there might not be any. Just bear that in mind. Okay, now it's time to have a look and see if you can spot any pairs of perpendicular lines. So a reminder, those are the lines where you can see a right angle has been made. Can you spot any perpendicular lines in those shapes? Again, remember, some shapes might not have any perpendicular lines. Okay. This is another interesting activity that really shows you how well you are understanding what these parallel and perpendicular lines actually look like. We're focusing on perpendicular lines for this activity, and it's asking you which dots you should join up to make a pair of perpendicular lines. Just a little side note, when we are looking at lines in maths, we label them by naming them after the points they start and they end at. And you'll see what I mean about that in a minute. But for now, just have a look and see. If you joined up any of these dots, could you make a pair of perpendicular lines? Could you draw a right angle by joining up any of those dots? I'll give you a clue. You're looking at joining up 3 of the dots using 2 lines. Can you make a pair of perpendicular lines? Okay. If you decided to join up those 3 dots there, well done, you have made a pair of perpendicular lines. So this first line here, we call that line AB, because it starts at A and it finishes at B. And the second line here, we call that line BD, because it starts at B and finishes at D. And these 2 lines here, if we join them up, they do make a right angle. They do make that capital L shape. It is upside down, but it still is a capital L shape. So because we've made a right angle, we have made a pair of perpendicular lines. Okay. Here is a shape, and it's a quadrilateral. It has 4 sides, and I'm going to show you some statements about the shape, and I would like you to try and work out if each statement is true or if it's false. And we are looking in particular at the statements that are false. Just so you know, the corners of the shape are labelled A, B, C and D, because like the previous activity, we may need to name the corners or the lines in our answers. Okay, so the first statement, line BD is parallel to line AC. The second statement, line AB is perpendicular to BD. Line AB is parallel to line CD. And line AB is not perpendicular to any other lines. Have a look at those statements again, take some time. Think again about what parallel lines are and what perpendicular lines are, and see if you can work out which of those statements are true and which ones are false. We are looking for the ones mainly that are false. So pause the video now and have a look. Okay, Going to reveal the answers to you now. There we go. So those are the answers there. Line BD is parallel to line AC, and line AB is not perpendicular to any other lines. So the top statement and the bottom one are true, and then the central two statements, they were the false ones, and hopefully you were able to spot that. Okay. That is the end of the video for Friday. Hopefully that has been useful to you. You can now have a look at Friday's work on the website and try and work your way through it. And of course, always refer back to this video if need be to help you. And we'll be back with some more maths next week.